Yeah, so for -1, you have to look at the qualifiers right here and decide which rule you're going to plug it into for this function. Are you going to plug it into the first rule or the second rule for this function? Yeah, you plug in the first one because the first one it says x is less than or equal to 2, and -1 is less than or equal to 2, so you plug into the first one. You're going to get -2. So, -2 right there. And then 0, same thing. You're going to plug into the first rule. I'm going to get -1. And if I plug in 1 to this function, 1 is less than or equal to 2, so you'd plug into this first one, which would be 0. And then finally 2. Can I plug 2 into this first rule? Yeah. It says 2 is less than or equal to 2. And if I plug 2 into that, I would get 1. All right, and then something happens when we get to 3. I plug 3 into this function. 3 is greater than 2, so we got to plug it into the first rule or the second rule? Second rule. So you get 9. And then the last one, you're going to plug it into the second rule, you get 16. All right, now let's graph this guy. Okay, so for -1, we go down to -2, so I go bam, 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 and I put a dot right there. And for 0, I go to -1. And for 1, I go to 0. And then for 2, I go to +1. And then something happens when I go to 3. When I go to 3, I jump up to 9. So 3 would be right there, and I go up to 9, so it'd be 2, 3, 4, 5, 6, 7, 8, 9. So I put a dot right there. And then the last one, 4, that we did, we have to go all the way up to 16. 10, 11, 12, 13, 14, 15, 16. Okay, so I put a dot way the heck up here. All right, you might not have space to put that last dot. Maybe you didn't give yourself enough space because you didn't pay attention to the biggest y value, but that's okay. All right, now can I just connect all these dots? Is that what I do? I go bam, bam, and then like that. Whoop, well, more straight. Is that what I do? Nah, Doug. That's not what you do. This is a piecewise function. Okay, we gotta lift our pencil for every new rule. So for x minus 1, that's the left side of this graph. We would connect these dots because any x value that is less that 2 is 2 or less than, we're gonna plug it into this first rule, and that's gonna be on this line right here. Like if you were to pick -1/2 and plug it into this function, you would plug it into the top rule. You would get -1 1/2, so it would be right on this line. And then when we plug in 3 and 4, this is what is happening. You're getting this thing that's increasing a lot. Now you guys have seen parabolas before, x squared. You know that this function is supposed to do something like this. It's supposed to do a parabola thing. But we're not supposed to plug in anything to that function that is not greater than 2. So what about all these numbers right here between 2 and 3? What about all these numbers? They don't have any points in this area. So what would you do with those numbers? Would you plug those numbers into the first rule or the second rule? You plug in the second rule, but do you really want to do that? Do you want to go 2.5 and square it? No, because I can't do that in my head. I'd probably bust out a calculator or make fractions and do it that way. Hey, let's do that. Let's make a fraction. 2.5. Yeah, let's plug in 2.5. But let's not plug in a mixed number. Let's plug in 5/2. That'd be the same as 2.5. What are we going to get for our y value if we have 5/2? If we take 5/2 and plug that in, what do we get? 5 times 5 is? 25. And then 2 times 2 is? Quattro. Now, if I want to graph this, I would normally put that back into a mixed number. How many times is 4 going to 25? 6 times, 1/4. So right here, right in the middle at 2 1/2, that'd be right there. We're going to go up to 6 1/4. So 1, 2, 3, 4, 5, 6, and then 1/4. So I'm going to put a dot right there. So this line continues on right there. But then still, what's going to happen between 2 and 2.5? We got to pick a number between 2 and 2.5. Well, that sounds complicated. This is when open dot comes into play. Now, the function says I'm not supposed to plug in 2 to the second rule, but I'm going to plug it in anyway so to see where this line is supposed to go to. So let's plug in 2. What do I get when I plug in 2? Cuatro. So I'm going to go up to 4. 1, 2, 3, 4. And I'm going to put an open dot right there. And then I connect the line to that. So this is what my graph looks like. It goes right here, and then it makes this magical jump. And then we have the second rule right here. Now this is a function. Like Mauricio said, you guys can do the vertical line test to see if it hits the function at 2 spots. This is the only spot I would be concerned with because it looks like they're right on top of each other, but that's an open dot. So the function, the vertical line test only hits the function once, and that's right there. So this passes the vertical line test. This is a function. Another thing we could do if we know it's a function, actually we could do this if it's not a function, but we can find our domain and our range. Now I want to do this just because it's interesting. All right. Any x value on this horizontal axis, can I plug in any x value to this and get a result? Yes. The answer is yes. And so your domain would be negative infinity to positive infinity, all real numbers. What about the range? Now the range is kind of interesting. It looks like this arrow is pointing down, so our lowest range number would be negative infinity because we can't find the lowest. But then it stops right here at 1. So this interval from negative infinity, let's put a negative infinity down here. This is negative infinity all the way to 1. It stops. So I'm going to say negative infinity to 1. And it looks like 1 is included in the range because there's a solid dot right at 1. And then where does the range pick back up at? There's a gap right here. That'd be 2, 3, 4. It picks back up at 4, so I'm going to say union, and I'm going to put 4. Does 4 get a bracket or parenthesis? It'd be cool if we got parentheses. Yeah, parentheses because it's open. So I go like that, and then what's the highest range number? Yeah, it keeps pointing up, so we don't have a highest. We're going to say infinity. So that's our domain, that's our range. That is how you graph a piecewise function. Oh, hey, here's another side question. Where is this function increasing? Going from left to right, where is this function increasing? Am I increasing or decreasing right here? Increasing. And then I jump up this part, increasing, decreasing. So we're actually increasing on this whole function. Okay.